A very good evening. My name is Suvan, Anarakin Oganadan, and my experiment group is a T6C, and matrix number is a 22301689. And today, I would like to conduct an experiment which is about the projectile motion. Okay. Okay, let's remake a little bit review of this experiment. But before we go in that, we need to know what are the objectives that are we going to observe in this experiment. First is about the projectile range as a function of inclination angle. Second is a maximum height as a function of projection angle. Third, we want to determine the value of gravitational acceleration. And lastly is projectile range.
Now, we will use the ballistic unit for launching the steel ball. We can adjust the angle of projection by loosening and tightening the screw. Set up the initial angle, which is 25, and each will increase by 10 until reach 65. This is the recording paper to mark the range of the steel ball, and the ball will land inside the box. This is the meter rule to observe the maximum height of the steel ball by using our eye. Finally, this is the overall view. How do the experiment looks like?
Okay, that's the overview of the experiment. Now we proceed to the question. The first question is what do you think is the best angle of a projection to start with the experiment with? Personally, by putting 45 degree is ideal angle of a projectile motion, and it because that the steel ball able to stay longer, stay for a long-term duration in the air, and this will lead a maximum range, projectile range on the x-axis. Okay, for the second question is suggest a way to accurately measure the height of projection of a steel ball in this experiment. I believe that by using the formula h equals to v naught square over 2g and times with the sine squared theta will solve this problem. It is because that if we use the meter rule and we observe with our eye, we couldn't read it properly. It because that the ball fly in a high speed and we couldn't read properly of the maximum height of the projection of a steel ball. So by using the formula, it's much more accurate than observe with our eyes. Okay, now we were going to the third question. Suggest a way to determine the time taken for the projectile in this experiment to reach the maximum height. I believe that by using the formula Vfy equals to Viy plus At will solve this problem. What is Vfy? So Vfy represent the final velocity at y-axis. Viy represent the initial velocity at y-axis. And the A here we will replace with G, which is 9.81 in terms of negative. Let's redo a little bit example. Imagine there's a steel ball here, which is a project, and given that the initial speed is 2.43, and for sure that the velocity will become decreased as it reach the maximum height, and we can conclude that the Vfy is equals to 0 meter per second. Okay, from using by using this formula, Vfy equals to Viy plus A will become G times with the time. So here is it to the solving. Vfy equals to Viy plus At. So the A I will exchange to G, which is in negative, and the Vfy is 0 because at the maximum height, the velocity will become 0, and the initial speed is a 2.43,
and we will take the t as a subject to determine the time taken. And here's the answer. We can determine the time taken when it reached the maximum height.
Okay, the last question is from the theoretical physics point of view, will the type of material of the ball will affect to the range and height of the projection? I believe that the answer is no. It is because that any kind of material like alloy, wooden, or steel, any type of material for this ball does not affect to the result in range and also the maximum height.